In this worksheet, we're going to be discussing solving equations. And in statistics, you use several different equations, including the z-score formula. Later, you'll be using some other equations. So what we want to discuss is the algebra part of solving equations. You will see at the very beginning there is an equation that's given to you, y equals 3x plus 4. And what they want you to do is solve for a specific variable. In this, they want you to solve for x. So if you notice to the side, your original equation is y equals 3x plus 4. If I want to get x alone, that means I need to remove the 4 and I need to remove the 3. So if you notice the very first step, your 4 is a positive 4 in your original problem. To get rid of this, you always do the opposite of the operation. So since this is a positive 4, I'm going to subtract 4 from this side, but whatever I do to one side of the equal sign, I have to come over and do to the other side. Remember, the original equation is the y equals 3x plus 4. So I'm going to write this first. Plus 4. So I have y equals 3x plus 4. So you can see that I'm doing minus 4 and then minus 4 on this side. So that's those two. Now, the y minus 4 comes down. Notice the 4 minus 4, those are now gone. They cross out because that becomes a 0. So we have left y minus 4 equals 3x. Now, remember, my goal was to get x alone. So if you notice there's a 3 right here beside the x, when there is a number beside a variable, that means multiplication. To remove something that's being multiplied, we divide. So that's when we can use the fraction bar under both sides for division. So whatever I'm wanting to remove, I put in the denominator. And that way, now I can take the 3's and cross those out. And then I have x equals y minus 4 over 3. Also, you could simplify this by writing each of the variables over the 3, or each of the parts of this equation over the 3, and you could simplify the equation as x equals, notice it would be like having a 1 in front of the y, so it'd be 1/3 y minus 4 over 3. Either way is fine. So now we have the equation from the y form, y equals form, now to the x equals form. So you're going to be taking an equation now, the z-score formula, and they're going to ask you to find the value x first. Now, if you take and solve for x, we're going to do the same type of thing. Remember, in this is z equals x minus the mean divided by the standard deviation. If I want to solve for x, I need to remove the standard deviation and the mean away from the x value. Remember your fraction bar? That is considered division. So in this case, I have z equals x minus the mean divided by your standard deviation. Now, I want to solve for x, so I'm going to take and write on each side of this a parenthesis. I'm trying to get rid of what's being divided here first. So the opposite of division is multiplication. So I'm going to multiply both sides by the standard deviation. And now the standard deviations will cross out. And I have the standard deviation of z equals x minus the mean. Now keep in mind, they want us to solve for x. So if I solve for x, that means I need to move the mean to the other side of the equation. Notice right now, it's a minus, a subtraction, so I need to add the mean to the other side. So I'm going to come and write plus mu. Now, this is a positive here, so I'm just going to put mu over here. So notice here, these would cross out. So now I have this. I have x equals the mean plus z times your standard deviation. That is the form when you're trying to convert when you know the mean and the standard deviation and you know your z-score, you can find your score. So now what they're going to do is give you 40, they'll give you 5, and they're going to give you a z-score. You're going to plug these into this equation and solve for x. Okay, the next page. The next page gives you a formula. It says using the proportion formula. Now remember, the proportion formula is p hat equals x over n. And what they're going to ask you to do is solve for n first. So you're going to go through the process of solving this equation. We have p hat equals x over n. They want us to solve for n. Now, if you notice, n is in my denominator, so this is division. I'm trying to get n alone, so I need to somehow get rid of this x, but the only thing I can do first is get rid of the n because it's being divided. So I'm going to come and put parentheses around both sides of my equation. I'm going to write the n on both sides, and then these will cross out. So right now I have x equals n times p hat. Now, what I'm trying to do is get n alone. Remember, this is being multiplied right there. So the opposite of multiplication is division. I want n alone, so I'm going to draw a fraction bar, and put p hat. And now these cross out. So I have a new equation that says n equals x divided by p hat. Now that we have it in the right form, we can take, it says if we know that p hat is 0.36 and the number of successes x is 59, we can now use our equation and plug in and find our sample size, the n. Notice this, always round your answer up to the nearest whole number. Round your answer to, oh, in this particular one, they're just saying round your answer to the nearest whole number. It didn't say up. Usually you do. If you have n as your sample size, usually we round that up to the next largest number. But right now for this one, it just says round your answer to the nearest whole number. So that's what we have. Okay. There's some other formulas called the margin of error. You can kind of follow through and see what's going on here. But notice they're going to ask you, once you follow through this, your margin of error formula, you finally rearrange it and you come up with this. N equals p hat times 1 minus p hat times z alpha divided by 2 divided by your margin of error squared. That's called your sample size formula. And they're wanting you to take and use the values that's given here and fill in the blanks. Now I want you to know, z alpha divided by 2, that's just a notation. You're going to remove the whole entire z alpha divided by 2 and actually type in 1.645 in the place of that. But you're going to take and put in your p hat, put in your z alpha divided by 2, put in your margin of error, and then type this whole entire thing into your calculator and find your sample size. Notice in this one, they asked you round your sample size up to the next whole number. Okay. Now, the last thing is they kind of review plotting points because we're going to be dealing with linear regression. And notice they review your x and y axis, your origin. They tell you that when you're looking at these, this section right here is called quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. And they're going to ask you to plot some points. So you're going to take your grid, you're going to take these 2 points and you're going to plot those. Remember, in an ordered pair, your first one is your x, this is y, that's your first point. This one is x, this is y, this is your second point. Now they're wanting you to take and plot this point on this graph. Remember, this is your x-axis, that's your y. So if you're looking at this point 4, -2, it means you're going to go from the origin over 4, and then -2 means down 2. And you're going to plot a point, and that will be this one. Then you're going to turn around and you're going to do this one. Always do your x and then your y. Okay. Next thing you're going to talk about is probability plots. And this is an example of a probability plot. Always know that if your points are very close to a line, when you plot those points, it's a linear equation. that would actually go through these points. That's what forms the line. But if your points are very close to the line, that means that is a normal, we can assume it to be a normal distribution from working with our normal probability plots. And then if the points are far away, that means we cannot assume something to be normal. You'll be doing this in section 7.3 in your statistics.